Here, a person is pumping gas into their gas tank, and the chart that they give us is in gallons per second, like how fast the gasoline is going into the gas tank right there. So we need to explain the meaning of this integral and use a right Riemann sum for part A. So the chart is in gallons per second. So when you integrate gallons per second, you're going to get gallons. So the meaning of that integral that represents the total amount of gallons of gasoline that the customer pumped into their gas tank. You got to specify the time period from t equals 60 seconds to t equals 135 seconds and be very specific for that. So that's the first part of part A. Still on part A, we're doing a right Riemann sum only in between 60 and 135. So you're only talking in between 60 and 135. And so if we use the right Riemann sum, that means you start at the right side of your interval. You go 0.05 times the distance between 120 and 135 times 15, and then you go plus zero point 0.1 times the distance between 90 and 120, which is 30, and then you do plus 0.15 times the distance between 60 and 90, which is again 30. And there's my work for that. A right Riemann sum is 8.25 gallons. We get a calculator on this problem. Part B says, must there exist a value between 60 and 120 such that the derivative is equal to 0? Now, you can actually use a mean value theorem or Rolle's theorem on this problem, but that is one of your main theorems right there. And so typically when I see the derivative is 0, like from your blue packet here, like that's typically when I use the Rolle's theorem. So they told us the function was differentiable. And remember, whenever something is differentiable, that automatically means it's continuous. The reverse of that is not always true. If something's continuous, it might not be differentiable, but if it's differentiable, that automatically implies continuity. So I kind of jotted that down, and then that just means f is continuous and differentiable. And then the third stipulation of Rolle's theorem is that f of a has to equal f of b. So they're talking about between 60 and 120, and f of 60 and f of 120 are both equivalent to 0.1. So those are the three stipulations that have Rolle's theorem applies. If it's continuous and differentiable and f of a equals f of b, Rolle's theorem guarantees a spot where that derivative is equal to 0. You also could have used the mean value theorem. You still got to mention it's continuous and differentiable, and then that's the only two stipulations you need for the mean value theorem to apply. And then you have to show that the f of b minus f of a over b minus a is equal to this f prime of c. So like once you calculate the f of b minus f of a over b minus a, you get 0. So that means that derivative has to be equal to that number because your mean value theorem says your that slope formula is equal to that derivative at that point. So two different ways that you can show that that derivative must be equal to 0. So mention the stipulations, mention the theorems, we'll get credit for that. And then we need our graphing calculators for part C and part D. So it gives us this function, and then it says find the average rate of flow of gasoline. So this is our average value formula that we're using right here, the integral. You're going to do 1 over b minus a times the integral from a to b. So there's my average value formula. And then I used my graphing calculator for that, did the math 9. I entered this into my calculator, and that was already kind of in there as my y1. So I was able to just kind of use that alpha trace there. But do the math 9. Make sure you practice that on your own with the calculator. Anytime you use the average value formula, the units will stay the same. So this is in this is in gallons per second. So this is in gallons per second, it tells us. So you're gonna stick with gallons per second. It is true when you integrate gallons per second, you get gallons, but then you're timesing it by that 1 over 150, times it by put the seconds on the bottom once again. So make sure you practice that on your own in the calculator. Make sure you can get that and let me know if you can't. And then part D is just saying find G prime of 140. So this was the G of T. I already had that in my calculator as my Y1. So I was able to use the alpha trace when I needed it. And I just did the math 8. So the math 8 will take the derivative of that for us at that 140. And then you're doing a derivative. It starts off gallons per second. That's like a velocity units. When you do the derivative of that, that's going to turn it into the acceleration units right there. And so I had to stress then it asks us to interpret that. So that's the rate of flow of the gas changes at that rate, or you can say it decreases at that rate of 0.005 gallons per second squared. But make sure you practice the calculator stuff there with C and D, and nice little problem right there. speakers.